Today we are going to finish 9.4 polar coordinates and polar graphs. In this lesson, we are going to review how to convert between polar and rectangular coordinates, how to plot graphs using calculators, and how to find the derivatives. This is what we are going to learn something new here in this lesson. So given polar coordinates, the origin, what we call the pole, and the angle theta and r. This is what we use for polar coordinates, r and theta. So let's have a look how do we graph points in polar coordinates. So for example, p, r equals 4, theta equals 5 pi over 3. So first we look at 5 pi over 3, 1, 2, 3, 4. So this is point P. If you look at point Q, point R, r equals a negative value, theta equals 5 pi over 4. 5 pi over 4 is here. R equals negative, that means we are going to the opposite direction of 5 over 4. So point R is right here. In pre-calculus, we also learn the relation between x, y, and r theta. So look at this triangle. Cosine theta equals x over r, sine theta equals y over r, tangent equals y over x, and x squared plus y squared equals r squared. So x equals r cosine, y equals r sine, and r equals square root of x squared plus y squared. And based on this relation, we can convert from polar to rectangular. So for the first one, given r and theta here, how to convert it into rectangular system. So x equals r cosine, y equals r sine. We plug r and theta in. 5 pi over 6 is a special angle. The point in rectangular system is negative radical 3, 1. Now how do we convert from rectangular to polar? Most of the time we need to draw a picture. 3, negative 3 is in the third quadrant. So r equals square root of 3 squared plus negative 3 squared. And tangent of theta equals y over x, which is negative 1. So our answer will be 3 radical 2 and negative pi over 4. How do we convert the equations between rectangular to polar system? Given rectangular equation, y equals r times sine of theta. So r equals 4 over sine theta. It's a polar equation. So r squared equals 25. So r equals 5. So let's have a look at how to convert from polar to rectangular. R sine theta equals y. Give us a horizontal line. Y equals 3. So if we multiply r for part b, or if you don't realize, we can first switch cosine using x over r. Now we multiply r on both sides. R squared equals x squared plus y squared. And we can compute the square. In the circle, center at 1 and radius equals 1. And last one, theta equals a fixed angle. So it will give us a line with the angle 2 pi over 3. What's the equation for this line? We can apply tangent on both sides. Tangent theta equals y over x, tangent 2 pi over 3, negative radical 3. So this gives us y equals negative radical 3x. So this is what we learned in pre-calculus. Let's have a look at the graph of polar coordinates. So how do you graph polar functions? So first you click mode in your graphing calculator and you are going to change to polar system. And if you look at the graph, it will look like this. And now you can click trace, it will show you 0. So you start from here. And if you press the red arrow, it will show you the direction. As theta increases from 0 until 2 pi, it will come back to 0. So this will finish the whole circle, whole graph here. So let's have a look at how do we take derivative in polar coordinates. To find the slope of a tangent line to a polar graph, r equals a function of theta. So first we change r and theta into x and y. So x equals r cosine, y equals r sine. So both x and y are function of theta here. So dy over dx based on parametric equation will be dy over d theta and dx over d theta. because r is also a function of theta, so we have to use the product rule when we take the derivative for the numerator and denominator. So same thing, horizontal tangent when dy over d theta equals 0, and vertical tangent when dx over d theta equals 0. Let's have a look at one example. So find dy over dx and the slope of the graph at theta equals pi over 6. Find horizontal and vertical tangents. So first, if you look at the graph of r equals sine 2 sine theta, so first you click mode, change it to polar, graph it. So this is the graph, and if you, when theta equals 0, start from here, and when theta equals 2 pi, it will come back to this point. So the interval, you can set it, when you set up the window for theta, you can change it to theta equals 0 to 2 pi. And if you use your calculator, you can use second calc to find the derivative dy over dx. You can directly find the derivative dy over dx as theta equals pi over 6, which give us negative 8.66. And also you can use the solve it by hand. So the slope equals dy over d theta, dx equals dy over d theta over dx over d theta. So first we have to find x equals r cosine, y equals r sine theta. We plug r in. So next we take the derivative. You can use the product rule, and this is the answer. And you can simplify it, or you can directly plug into theta equals pi over 6. The answer will also give you 8.66. And the next one, we are going to find the horizontal tangent and the vertical tangent. Horizontal tangent dy over d theta equals 0. So we set the numerator equals 0. So if we simplify the numerator a little bit, this will give us 4 sine theta cosine theta equals 0 plus 3 cosine equals 0. Now we plot this into rectangular equation system and treat theta as x. And if you have a look, change the mode to function and plot it. So from 0 to 2 pi, there will be 1, 2, 3, 4 roots. And theta here in this case equals 1.57, 3.98, 4.71, 5.43. And also for the vertical tangent, we set dx over d theta equals 0. We get two solutions, theta equals 0.439 and 2.702.